a short video this morning. We're making our first part for the regulator clock. It seems that in doing a little research, I actually started this project 4 years ago. So it's been sitting on the shelf ever since. If you watch my previous videos, you know that. And so I've done a little research and found the parts that I needed. So now I'm going to make the first part. And normally the old way would be to saw this out by hand and polish it and do all the necessary tasks pretty much by hand except for the drilling. In this case, we're going to do it on the CNC machine. So we've got a TAG CNC mill, old one, and we're going to cut this part out. Right now we're just milling a circle, which is going to be a couple little slots in the pallet arm. The pallet arm is what we're making. So we got to make some slots for the pallets, so to fit into. So that's the first thing we're going to do. And then after this, we're going to cut the part out itself. So I'll fast forward through part of this. Right now I'm using a 16-inch end mill, and we're making a slot slightly wider than that. So it's making some extra passes either side of the center in order to do that. So let me show you what I've done. I've done some look through the book, done some reading, and so let me. I don't know if the camera will show this or not, but there's the pallet arm. That's my drawing of the pallet arm, and you can see the little slots at the bottom of the arms. That's what we're doing now, and so it's pretty well laid out in the book. There's a picture of the same thing from the book. It uses British drill sizes, and I've converted it to whatever I want for the little screws and stuff that need to be put in. But you can see, I guess, that my arm's not quite long enough, but you can get an idea of what we're making. So this is a simple task for the CNC machine. So let me bring you in and take a look at what's going on here. See if we can zoom in on this. You'll see in the background I've got a 3/16" end mill back there. That'll replace this end mill once I get the slot done. So it's a piece of 360 brass. You can see there's an aluminum backing plate that's expendable, and you can see some toe clamps holding that. My friend Walter Macy up in Canada sent me those toe clamps, and for this purpose they came in very handy. You see I got some clamps behind them to back up the situation. Whoops, there goes the compressor. We're blowing air on the cut and keeping some of the chips out of the way since we're making a slot. So that's what's going on there. The toe clamps have some backing clamps because actually the little T-nuts on the TAG mill are not strong enough to hold. And even with the backing clamps, I can push those right down the mill table with no problem. So, but everything is tight, should be just fine. So, I don't know how long this process is going to take. I have to go around, look at the screen and see what's going on. But that gives you an idea what's going on. We'll just... I forget how wide this slot is. Looks like it's 65 thousandths wide, looking at my drawing. So Of course, the end mill is only a 1/16 of an inch, so it's not it's not quite wide enough. So actually, it's better to do it this way because I should get a true 65 thousandths, even though it's a new end mill, but still. Anyway, that's what's going on. I might add also that the piece of brass is being held to the piece of aluminum by, there's painter's tape on both surfaces, and then they're super glued together. So should be fairly easy to remove when the time comes. And the piece of brass looks like it's just barely big enough, and it's the only piece of brass I've got the right size. So we're hoping that it all works out okay. Hopefully we won't have any bad things happen. So, anyway, we'll just let this run. I think I don't think it's going to go for too long a period of time. The depth, I think, let's see, the slot depth is 1/8 of an inch. So let's see. Right now the slot is down almost 100 thousandths, so we don't have far to go. So I turned on the camera right at the beginning, so it's only going down about. Whoops! I think it's done. Okay, I'm going to shut the camera off now and reset up, and we'll start it again when we start cutting out the parts. That was quick. Okay, it's been a couple minutes. I'd say it's been about 5 or 10 minutes. I changed cutters, and I'm sorry I can't get on top of this a little bit more. But I'd have to move my camera. Maybe I should do that. Get a better shot of what's going on. But we got to see underneath the spindle anyway. So it looks like for some reason Cam Bam made an extra cut, and I just left it in there, and it doesn't seem to hurt anything. I don't know what the reason was. So it went out, made an arc type cut in the first pass. Now it seems to be just making a normal pass around the item. So we're running at full speed here. We're pushing at just a slow speed rate, maybe about 10 inches per minute or something. Not a heck of a lot. It's not going to take a lot to go through this. This is a 3/16 inch thick piece of brass, so it's gonna go through it pretty quick. I'll probably end this video once this cut is made. I'll brush it off, and then off camera I have to drill about 5 to 8 holes. I'm not sure how many I'll drill. I'm not sure if I'll use all the screw type connections or not. I may use some Loctite in a couple areas where they've got screws, so haven't quite decided that yet, but we'll see. So this is the pallet arm for the clock. So they'll hold the little pallets, which I'll make from a piece of tool steel, and I can just leave that and polish them, or I can harden those pallets if I want. But that'll probably be the next step after this. There's a bunch more steps, a bunch more parts that need to be made to operate the pallet arm. It's called a crutch, and it connects to the back of the pallet arm and goes down to make contact with the pendulum rod, and that's what runs the clock. So see if I can do something with the camera here. I don't have much else to tell you, so I'll move the camera a little bit. Maybe I can zoom it in a little bit more. But basically, it's just doing the same thing. So this is certainly easier than trying to saw this out with a hand coping saw, jeweler saw. And it's very accurate. So I could drill the holes with the CNC too, but I've chosen not to do that. I can still do that if I like. I can go lay out the CAD and add another profile to this drawing and go ahead and drill the holes. I don't think any of them have to be entirely accurate. They're all clearance holes, I think. So I could actually drill them with a small end mill. This is easy. At the end of this routine, it's easy to go back to 0, which is the center. You can see where that's located. The end mill's made a little mark there. That's got to be drilled out for a collet. So anyway, that'll give you an idea what's going on with this project at this point, and I'll try to show some more CNC work. Looks like the crutch itself will be a CNC job because it's got some curves and stuff in it that might not be too easy to do, and it's a fairly thin piece of brass, only a 1/16 of an inch thick. So I'll probably super glue it down to something and cut that out with the CNC mill too. So saves a lot of labor, and it's a good thing, a good way to go. So I guess at this point, this thing's about done, I think. Let's see where we're at. I gotta walk around here and look at the computer screen. So we got to go down 187,000, so we're down 110,000 now. And you've watched almost the whole process. I could speed this up. We're just cutting brass. The feed rate could be higher, but especially I'm using a 3/16 inch end mill, which is pretty hefty. So I could certainly move it faster. Anyway, I'm going to call off now because it's just going to be a few more minutes of the same thing. And we'll get this posted, and maybe I'll decide what to do about the hole. I think maybe I'm just going to drill the one center hole, and that's it. The rest of the stuff I'll do later on or not do. We'll see. Anyway, I'll call off now. Thanks for watching.